Hello everyone, welcome to the video lecture series on Chemical Engineering Thermodynamics 1. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the previous chapter, which is a heat effect. So in this lecture, we'll talk about the Hess law and calculate various numerical which based on Hess law. So let's start with the discussion of Hess law. Hess law states that the net heat released or absorbed in chemical reaction is the same whether the reaction take place in a single step or series of steps. This is known as a Hess law. To understand this, let's take one example. Let's take methane and oxygen example. When methane is react with oxygen, it makes CO2 plus 2H2O. Heat released during this reaction is minus 819 kilojoule, but this reaction occurs in two steps. At step 1, when the methane is react with 2O2, it will give CO plus 2H2O plus 1 half O2. And again this 1 half O2 is react with the CO and make CO plus 2H2O. So this reaction occurs in two steps. In step 1, enthalpy change is minus 607 kilojoule, where in step 2, enthalpy change is minus 283 kilojoule. Now if we are going to summation of this both enthalpy change, we will get same enthalpy change for the reaction. So from this can say that heat release in chemical reaction is the same whether the reaction take place in single step or series of steps. So now let's talk about equation for the Hess law. Equation of Hess law that can be given by delta H naught is equal to summation of enthalpy change or heat of formation for product minus summation of enthalpy change or heat of formation of the reactant. This is a basic equation for the heat of reaction or heat of formation which already studied in previous lecture. Now let's take some numerical to understand this Hess law. So let's start with this numerical. So let's calculate this numerical. So in this numerical, given that calculate the heat of formation for methane gas from following heat of combustion data. So given that various heat of combustion data in form of the reaction. First reaction that can be given by CH4 plus 2O2 gives CO2 plus H2O. Heat of formation for this reaction that can be given by delta H naught is equal to minus 890.94 kilojoule. Second reaction that can be given by C plus O2 gives CO2. Heat of formation for this CO2 that can be given by delta H naught is equal to minus 393.77 kilojoule. And third reaction that can be given by H2 plus 1 half O2 gives H2O. Heat of formation for this H2O is 286.06 kilojoule and sign is negative. So can say that delta H naught is equal to minus 286.06 kilojoule. Now from this reaction we have to find out what is heat of formation for methane gas. So first we have to find out where is the methane gas in this all reactions. So can easily say that this is a methane gas from this reaction. So this reaction becomes main reaction for us. Now let's find out what is product and what is reactant in this reaction. So reactant is a CH4 and 2O2, where product which is a CO2 and H2O. So first we have to find out heat of formation for the CO2 and H2O that already given in this reaction for the CO2 and for the H2O. Heat of formation for element is negligible, so we are not considering heat of reaction or heat of formation for the element which means only one molecule such as the oxygen, hydrogen, carbon, nitrogen. So this all known as the element. So we are not considering the value of or heat of formation value for that particular molecule or the element. We only consider heat formation value for the compound or substance. Compound and substance which means two molecule and more than two molecules such as methane, carbon dioxide is known as a substance. So we only consider heat of formation data for the substance. So let's calculate heat of formation for the methane gas. So using Hess law can calculate heat of formation for the methane gas. So let's write Hess law equation. What is Hess law equation? Hess law equation that can be given by delta H of H naught of reaction is equal to summation of delta H naught for the product minus summation of delta H naught of the reactant. So let's find what is the product and what is the reaction and what is enthalpy change for the reaction or total reaction, which already given, which is a minus 890.94 kilojoule is equal to product which is a CO2 and H2O. So let's write delta H of CO2 plus delta H of H2O minus delta H of reactant, which is a CH4, which we have to find out. So let's write again minus 890.94 is equal to delta H of CO2, which is a minus 393.77 minus 286.03 minus delta H of CH4. So by calculating this, we will get value of delta H of CH4, which is minus 74.90 kilojoule. So now let's calculate second numerical based on Hess law. In this numerical, given that the calculate the heat formation for solid CaCO3. So we have to find out heat of formation for the CaCO3. So this equation becomes main equation for the what is reactant for this reaction? Reactant, which is a CaO and CO2. So heat of formation for the CO2 and CaO already given. So can easily find out heat of formation for the CaCO3 using Hess law. So apply Hess law equation to this numerical. So Hess law equation that can be given by delta H naught of total reaction is equal to summation of delta H naught of the product minus summation of delta H naught of the reactant. Okay, so what is total heat of formation reaction, which is a minus 178.15 kilojoule, then delta H naught of the product, so can write that product, which is a delta H naught of CaCO3 minus delta H naught of reactant, so delta H naught of reactant, which is a CO2 minus delta H naught of CaO. So let's write again this equation, which becomes 178.15 minus delta H naught for CaCO3, which we have to find out, minus delta H naught for CO2, that can be given by minus 393.77 kilojoule. So this minus minus become plus and 393.77 kilojoule. Then again value of CaO minus 635.77. So minus minus becomes plus. So 635.77. Now rearranging this equation, we will get delta H naught of CaCO3 is equal to minus 198.15 minus 1029.54. So by calculating this term can get value of or heat of formation for CaCO3. So let's write heat of formation for CaCO3, which is minus 1207.69 kilojoule. So this is answer or heat of formation for the CaCO3. So let's calculate one more numerical based on Hess law. In statement given that using Hess law, the calculate heat formation of chloroform with following given data. So in this statement given for this reaction, and we have to find out formation of chloroform. So step 1, which is find out chloroform from these four reaction. So can easily find out chloroform from these four reaction. Reaction 1 which contain chloroform. So this reaction 1 becomes our main reaction. Then we have to find out heat of formation for the product and reactant. Heat of formation for the product such as CO2 and 3HCl. So heat of formation for the CO2 and HCl given in statement. Then have to find out heat of reaction for the reactant. So first we have to find out heat of reaction for the H2O. So heat of formation for H2O is given in this reaction. Then have to find out heat of formation O2. But we know that heat of formation for element does not consider. Then we have to calculate heat of formation for chloroform, which we have to find out. So calculate this numerical. To find out heat of formation of chloroform, let's apply Hess law. Hess law equation that can be given by delta H naught of total reaction is equal to summation of delta H naught of the product minus summation of delta H naught of reactant. So let's write first delta H naught for total reaction that can be given by minus 509.93 kilojoule is equal to enthalpy change for the product that can be given by delta H of CO2 and delta H of HCl. So let's write delta H naught for the CO2 plus delta H naught for HCl. But in reaction given that there is a 3HCl, so we have to multiply with 3 minus reactant enthalpy change for the reactant that can be given by delta H naught for the CHCl3 minus so delta H for H2O. Now let's put down value for this all term. So let's write 509.93. Let's write 509.93 is equal to delta H naught for CO2, delta H naught for CO2, which is a minus 393.78 plus 3HCl. So we have to multiply by 3 with HCl formation that can be given by minus 167.57. So this becomes our enthalpy change for the product. Now minus enthalpy change for the reactant that can be given by delta H naught of chloroform CHCl3 minus enthalpy change of H2O that can be given by minus 296.03. Minus become plus, so it becomes plus 296.03. By calculating this term, can find out delta H naught for chloroform CHCl3 minus 90.53 kilojoule. So this is becomes heat of formation for chloroform. So I am completing my lecture here. Thank you.